Hello, in this presentation, we will explore three key measures of spread in data: variance, standard deviation, and coefficient of variation. Data spread refers to how far data points are distributed from the center of the distribution. These measures help us quantify the variability within a dataset and understand how much individual values deviate from the average. Variance, represented by the symbol sigma square, this is the symbol sigma square, is the most fundamental measure of spread. It captures the average squared deviation of each data point from the mean average of the dataset. In simpler terms, it tells us how much, on average, the data points differ from the central value. To calculate variance, we first find the squared deviations from the mean for each data point. This means subtracting the mean from each data point, squaring the result to remove negative signs. Finally, we average those squared deviations to get the variance. An important thing to remember about variance is that it is expressed in the squared units of the original data. For example, if the data is in centimeters, the variance will be in square centimeter. This can make variance challenging to interpret directly. However, a higher variance value signifies a larger spread of data points around the mean. Imagine a normal distribution bell curve. A high variance translates to a wider curve, indicating more data points are farther away from the central value mean, which is standard deviation. SD is the square root of the variance sigma, denoted by the symbol sigma. Variance is denoted by sigma square and it is denoted by sigma. This transformation takes us back to the original units of the data, making it easier to understand and compare spread across different data sets because it considers the same units as the data. Standard deviation tells us how much, on average, the data points deviate from the mean in the original units, such as centimeters, dollars, etc. Standard deviation is generally the preferred measure of spread due to its interpretability. I'm repeating it again. For data students, it is very important. Standard deviation is generally the preferred measure of spread due to its interpretability. The concept of standard deviation becomes particularly interesting when considering the normal distribution bell curve. In a normal distribution, we can expect a specific proportion of data points to fall within certain standard deviation ranges from the mean. Roughly 68% of the data will lie within first standard deviation of the mean on either side. As we move further away from the mean, the proportion of data points decreases. Around 95% of the data falls within second standard deviation, and 99.7% falls within third standard deviation of the mean. We will cover standard normal distribution in our next lectures, in our coming lectures. Coefficient of variation. The coefficient of variation CV is a relative measure of spread that allows us to compare the variability of datasets within different units. It is particularly useful when comparing datasets with different means. Calculating coefficient of variation is CV is calculated using a simple formula. We divide standard deviation SD by the mean of the dataset and then multiply the result by 100% to express it as a percentage. This transformation allows us to compare the relative variability of datasets regardless of their original use. Students, you will find these notes, lecture notes on our website, which is given in the description below. Interpreting coefficient of variation. Just like with standard deviation, a higher CV signifies a larger relative spread of data points around the mean. Conversely, a lower CV indicates that the data points are clustered closer to the mean. The key advantage of CV is that it allows us to compare the variability of datasets even when they are measured in different units. For example, we can compare the relative spread of income levels in dollars and exam scores in percentages using the coefficient of variation. I am repeating it again for data students. For example, we can compare the relative spread of income levels in dollars and exam scores in percentages using the coefficient of variation. So these are totally different units, dollars and percentages, but we can compare them by through coefficient of variation. Choosing the right measure of spread. The choice between variance, standard deviation, and coefficient of variation depends on your specific analysis needs. The variance is useful for understanding the total variability within a dataset, but its scared units make interpretation challenging. Standard deviation is generally preferred due to its interpretability in the original units. However, it can be misleading for skewed data, where the mean might not be a good representative of the center. The coefficient of variation is the best choice when comparing the relative variability of datasets with different units. It's important to note that CV does not provide information about the direction of the skew, positive or negative. Thank you so much. Please subscribe and follow the channel.